Hello, Transcended here. So, in this video, we're going to talk about how to calculate the enthalpy using Hess's law. So, I've got three questions with me, which we're going to do together to help you understand the basic concepts of Hess's law. So, some of the few things that you need to know is that, let's say this is the main reaction that you've been given. Then you've been given reaction mechanisms. Like in this case, these are our reaction mechanisms. Okay, so the way it is, if you want to make your work easy, is to compare what you have with the, the main equation. So if you find that the reactants are not matching up, you need to reverse the other one. That is part of reaction mechanisms. And the moment you reverse it, the enthalpy is going to be affected. The sign changes. So if it requires you to multiply by a certain number, the whole equation by a certain number, even the enthalpy is supposed to be multiplied by a certain number. So we'll get to understand as we get to solve. Alright, so I'll start with the first equation there. So what do we have in the equation? We have CH2 CO plus 2 of oxygen, giving us 2 carbon dioxide plus H2O. So what is the first equation? The enthalpy is negative. It's 1.1. Alright, so we need to compare this equation with the main equation, because the question says, given the following two reactions and enthalpy data, calculate the enthalpy change for the reaction in which methane and oxygen combine to form that. Okay, so I'll look at this. Where is it in the main reaction? Here it is. Is it part of the reactants or the products? It's part of the products. But how about in this equation? It is part of the reactants. So we have to reverse this reaction. So meaning that the products will become the reactants. So it's going to be 2 carbon dioxide plus water, giving us 10, which is CH2CO plus 2 oxygen. So we've reversed it. So the sign of the enthalpy changes. It will become positive 981.1. Okay, so it's very important to understand that whenever you reverse it, the sign is supposed to do what? The sign is supposed to change. Alright, so what do we do now? Let's go to the second equation. So let's compare the second equation with this one. So methane is a reactant. How about in the main equation? It's also a reactant. Oxygen as well, it's a reactant. So there is no need of us to reverse this one because they are already matching up. So we have CH4. Use a different color for that. So we have methane, CH4 plus 2 oxygen molecules, giving us carbon dioxide plus 2 water molecules. Okay, so the idea is everything else. Okay, of course, let's try to indicate our enthalpy, negative 802.3. So the idea is you need to cancel out what's not part of the main equation. So what are some of the things that are not part of the main equation? So if you look at methane, is it part of the main equation? Yes, it is. Oxygen, it is. Carbon dioxide, it's not. So we want this one to go away. Water, it is. This one, of course, it's fair. We can see it clearly. Oxygen is not a product, so this one is supposed to go. Carbon dioxide. Do we have carbon dioxide in the main equation? There is no carbon dioxide, so this one is supposed to go as well. Water molecule as a reactant. There is no water as a reactant, so this one is supposed to go. Alright, so we need to make sure that these things that are on the reactants and products are supposed to cancel out. So even before that, if you look at the first equation with methane, so in the main reaction we've got 2 of methane. So what are we supposed to do? We're supposed to multiply the entire equation by 2. So this is going to become 2. This will become 4, 2, and 4. So even the enthalpy is supposed to be multiplied by the 4. Okay, so I'll remove that. So now, what do we have? So this is a 4. This is also a 4. So let's balance out now. So we don't want, so I put a star for the things that are not supposed to be part of the main equation. So I'll start with a carbon dioxide. So this carbon dioxide is supposed to cancel out with that one because it is on both, it is as a reactant as well as a product. We only want it to, we don't have it part of the main equation, so it's supposed to go. How about water? So this water is supposed to go because in the main equation there is no reactant that is water there. So it is one that we've cancelled. So out of the 4, how many are going to remain? So remain with 3 water molecules. So what else? So I'd put a star on this oxygen. There are 2 oxygen molecules there. So from the 4, how many are going to remain? So we're going to remain with 2 oxygen molecules. Anything else where I'd put a star? They are all gone. So let's try to combine what we have now as our equation. So remaining with methane, 2CH4, and the oxygen there, 2 oxygen molecules, giving us, we have this as the only product. Okay, not forgetting there's water there as well. So CH2CO plus water. So this is a piece of information that we have, and it is matching up with the main equation. So you can be confident enough now to even calculate the enthalpy. So how do we deal with the enthalpy? So the enthalpy is going to be calculated by just adding what we have there. Okay, so what do we have? So we have got 4 being multiplied by negative 802.3 plus 981.1. So if you get your calculator there, 4 multiplied by negative 802.3 plus 981.1. So I'm getting negative 2,228.1 kilojoules per mole. So that's our enthalpy in this case. So let's look at the second question. So far what we've talked about, it's the only thing that is there is just making sure that it's kind of a puzzle now. You're just trying to analyze the reaction mechanism that you've been given so that they give you the main equation there. So after giving you the main equation, you then had the enthalpies that are going to remain on the left, which are affected by either the signs or even by the coefficients in case where you multiply. So this is our main equation in this case. So what is the question saying? The question says calculate the change in enthalpy for the reaction of calcium oxide and sulfur trioxide. So is this reaction exothermic or endothermic? So use the following equations and data. So you can pause the video and try it out from the basic concept that we've talked about in the first question. So it's a puzzle, it's kind of a game. So I'll start with the first equation there. So if we look at the first equation, do you have any compound that is common between the two equations with the main one there? So I can see this, it's also part of the main equation. Are they on the same side? Yes, they are on the same side. It's found on both as reactants. By the way, this application doesn't recognize this, so this means it's just telling you a separation between the reactants and the products. Okay, so the first equation is okay the way it is. Okay, we'll leave it the way it is because we have seen one reactant that is matching up. How about the second equation? Is it okay? So is there anything that we can see that is common? So calcium sulfate is a product in this case. It's also a product there. So this one will remain as it is as well. The third one, anything common? So I can see calcium oxide here. It is also part of that main equation. So in this case it's a product. In that case it's a reactant. So there is need for us to reverse this equation. So if we reverse it, what are we going to have? we're going to have, we'll start with calcium oxide as a reactant, giving us calcium plus half of oxygen. So remember we said that whenever you reverse an equation, the enthalpy is supposed to change the sign. So since it's a negative, it will become a positive 634.9. So let me even remove it from there so that we know that we've already dealt it away with. So we've remained with all the four equations, we've analyzed them, they are all okay. There's only one that required to be changed. Oh, by the way, there's one more down there. So the last one, we have hydrogen, oxygen, water. So is there a need for us to reverse it? So this is where now you need to think, because hydrogen and oxygen they are not part of that equation. So how then are you going to know what to do? So the basic idea is to analyze that we know hydrogen and oxygen, water, are not part of the main equation there. So we want them to cancel out. So meaning that they should be in opposition to the other equations. So if you look at the first equation, water is a reactant. So we would want it to be a product in this reaction so that we can cancel it out. So equally hydrogen is a reactant here. So where is it a product? It's a product in the second equation. So we would want it to cancel out as well. So this water molecule is going to cancel out with the one from the first equation. This hydrogen molecule is going to cancel out with the one from the second equation. Is there anything else that we can cancel out? So this oxygen as well can cancel out with this one there. Anything else that is common on both sides? Okay, so let's start by analysis from the first equation. So what have remained within the first equation? We've remained with SO3. Is it part of the main equation? It is, so we leave it. How about the sulfuric acid? Is it part of the main equation? It's not, so we'd want it to cancel out. So is there any equation that can cancel it out? Where is it? Do we have it anywhere? Yeah, we do have it in the second equation, and it's on the reactant side, so it will be able to cancel out. If we move to the second equation, we have calcium in solid. Then is it part of the main equation? If you analyze the main equation, there is no calcium in solid as a metal, so this one is supposed to cancel out. So where is it a product? So in the last equation, so it will cancel out. Anything else that we feel can cancel out? We've cancelled out all the things that are required. So we try to analyze what we have on the reactant side. So I can only see something remaining in the first equation and the last one. So giving us calcium oxide and SO3. The products were only remaining with calcium sulfate from the second equation. Okay, so calcium SO4. So this is actually matching up with the equation that we have. So how are we going to determine the enthalpy? We get the enthalpies from these other equations, and that's what S's law tells us to do. So from the first equation, it remained the same because we didn't reverse it. The second one, it remained the same, we didn't reverse it. There was no need to do that. The third one, which is this one, it had to change the sign because we reversed it, so it's a positive value. And this one remained the same as well, so minus 285.8. How many equations did we have? We had 4. So this is 1, 2, 3, and 4. So get a calculator there. Negative 132.5 minus 602.5 plus 634.9 minus 285.8. So what value do we have? We have negative 385. So negative 385.9 kilojoules per mole. So this is the enthalpy of that many equation there. Alright, the third one. Find the enthalpy of a reaction of magnesium oxide with hydrogen chloride. So in this case, guys, the concept is the same. So what you can do is just pause the video, try to solve it. Take your time, then come back. Alright. So magnesium oxide reacting with that. So this is our main equation. So all we are doing is comparing these other equations part of the reaction mechanism. We compare it with that equation. So I'll start by comparing from the first one. We have magnesium, we have HCl, magnesium chloride as a product, and hydrogen gas. So from these reactants and products, do we have anything that is common? So magnesium chloride is part of that equation as well as HCl. So HCl is a reactant, so even in the first equation it's a reactant. Magnesium chloride is a product, even in this equation it's also a product. So this equation will be maintained the way it is. The second one, we have magnesium solid, we have half oxygen, magnesium oxide. So anything that is common with the main equation, we have magnesium oxide. So in the first equation, it's a reactant. In this equation, it's a product, so we have to reverse it. So this one is supposed to be reversed. So it will be, so this product will become a reactant. So we have magnesium oxide in solid form, giving us magnesium plus half oxygen molecule. So remember we've said that whenever you reverse it, the enthalpy is supposed to change the sign. So since it's a negative, it will become a positive. So 601.6. Okay. So let's even remove it there. Okay, how about the last one? We have water, we have hydrogen, and half oxygen. Anything that is part of the main equation? Yes, we do have water in the main equation. Is it a reactant or a product? So it's a product. So even this one, we're supposed to reverse it so that it becomes a product. So if we reverse it, what are we going to have? We have H2 plus half oxygen as reactants. Then water becomes a product. So the moment you reverse it, the sign is supposed to change. So it will become negative 285.8. So let's cancel out now what is, so let us even remove that one there. So we need to cancel out the things that are on both sides as a reactant as well as a product. So let's put stars on the ones that are not part of the main equation. Is hydrogen part of the main equation? This hydrogen. So if you check the main equation, there is no hydrogen there. So this one we don't want it. Do we have oxygen in that equation? There is no oxygen. Do we have water? We do have. Magnesium oxide, we have it? We do have it. Magnesium in solid form? We don't. Half of oxygen? We don't. We got the first equation. Magnesium in solid? We don't have it. HCl, we do have it. Magnesium chloride, we have it. Hydrogen, we don't have it. So let's try to cancel out now these things with stars. Okay, so magnesium solid there. We'll cancel out. Where else is it? It's there. The H2 there is also an H2 here. This half oxygen, there's where else do we have an half oxygen? It's there. Anything more with a star? That's all. From the first equation, we are remaining with HCl and magnesium. So HCl has the only reactant to HCl. Plus, there is this magnesium oxide in the other equation. Those are the only reactants that we have. The products, I can see water here and magnesium chloride in the first reaction. So magnesium chloride and water. So this is the equation that we have, and it's exactly matching up with the main equation there, and that was our goal. So we can now get the piece of information that we came up with. So in the first one, it was maintained because we didn't reverse it. So it's negative 456.9. This one, we reversed it, so the sign became positive. This one was also reversed, so from positive it became negative. So it's negative 285.8. So get the calculator now and punch. We see what we're going to have as our answer. By the way, in the previous question, they had asked us to determine whether it's an endothermic or exothermic reaction. So whenever the answer is negative, we can say that it's an exothermic reaction. When it's positive enthalpy, it tells you it's an endothermic reaction, meaning that the reactants add more energy than the products. So negative 456.9 plus 601.6 minus 285.8. I'm getting negative 141.1 kilojoules per mole. So that's it when it comes to Hess's law. What is very important is to just understand to work around with the equations. When you reverse it, let the sign be negative. So thank you very much for watching and have a blessed day.